Okay, so if you've ever worked with data, you've definitely hit this wall. You get this amazing, promising data set, but it's just full of holes. And those missing values, they're not just an annoyance. If you handle them the wrong way, they can totally sabotage your entire analysis. Today, we're going to figure out how to fix them the right way.
This quote right here, it just nails it. Missing data isn't some minor inconvenience. It is a genuine threat to everything you're trying to do. Ignoring those empty cells is like seeing a crack in a building's foundation and just deciding to paint over it. Eventually, everything you build on top of that is going to be unreliable.
And it happens all the time, right? It could be a system failure, a simple data entry typo, or maybe someone intentionally skipping a question on a survey. Whatever the reason, those blank spots can lead you to completely wrong conclusions. So, how do we fix this without accidentally making things even worse?
Well, the very first step, and honestly the most crucial one, is you gotta play detective. Before you can even think about applying a fix, you have to understand the reason your data is missing in the first place. The why is what tells you the how.
Okay, so first up is MCAR. This is the simplest case, but let me tell you, it's also the rarest. Think of a lab device that just randomly glitches and fails to record a temperature reading. Or a survey respondent who just accidentally skips a question. There's no pattern, no rhyme or reason to it. The missingness is pure chance.
Now this is the one you're going to run into most of the time out in the wild. With MAR, the chances of a value being missing are actually related to some other piece of information you do have. The classic example is a depression survey, where, say, men are less likely to answer certain questions than women. The missingness isn't random overall, but it is random once you take gender into account.
And now for the most dangerous type, NMR. This is when the reason a value is missing is directly related to the value itself. For example, people with really high incomes are often the most likely to skip the income question on a survey. See, this isn't random at all, it's systematic, and it can introduce a massive bias into your results.
So, once you've diagnosed the why, you're at a crossroads. You've got a choice to make. You can take the easy path, or you can take the smart path, the one that actually preserves the integrity of your data.
Your two main options are what we call listwise deletion and imputation. Deletion is super simple. If a row has even one piece of missing data, you just delete the entire row. Poof, it's gone. Imputation, on the other hand, is a bit different. It's really just a fancy word for making an educated guess to fill in that blank space.
Now, here's the thing. Deleting rows is so tempting, right? It's fast, it's clean. But just imagine this. You have a survey respondent who carefully answers 39 out of 40 questions. Are you really going to throw away all 39 of their valuable answers just because one is missing? That's a huge loss of data, a huge loss of statistical power, and it can seriously skew your sample.
So, this brings us to the much smarter path, imputation. Let's dig into how we can make that educated guess in a way that's both responsible and effective. It's not about just making up data, it's about systematically estimating what that data point most likely would have been.
The key takeaway here is that each of these methods is a tool for a specific job. You've got mean imputation, which is like a quick and dirty fix. It's super fast, but it can really flatten out the true shape of your data. Then you have much more sophisticated tools, all the way up to the gold standard multiple imputation. It's more work, for sure, but it's way more accurate.
Let's just zoom in on the most common method for a second, mean imputation. Imagine you have an unhappy customer who rates every single thing a 1 or a 2, but they skip one question. If the average for that question across all customers is, say, a 5, the algorithm just plugs in a 5. You've just artificially turned your unhappy customer into an average one, completely distorting their real feedback. That's a huge problem.
All right, so you know the types of missingness and you know the methods. How in the world do you choose the right strategy for your specific data set? Let's break it down into a simple guide.
Here's a really solid rule of thumb. You might be able to get away with just ignoring or deleting missing data if, and this is a big if, it makes up less than 5% of your total data, and you are very, very confident it's missing completely at random, or MCAR. If you don't meet both of those conditions, you really need to be thinking about imputation.
So when is imputation basically non-negotiable? Well, if you have more than 5% missing data, for sure. If you suspect your data is missing at random. Or, frankly, if you just can't afford to lose all that statistical power by deleting tons of rows. It's all about preserving the integrity of your hard-earned data.
Look, for any kind of serious analysis, the undisputed gold standard is multiple imputation. Instead of making just one best guess for a missing value, it actually creates several different plausible versions of your dataset.
What this does is it acknowledges that we can't know the missing value for sure, and it builds that uncertainty right into your final result. This makes your conclusions so much more honest and reliable.
Now, I know this might sound super complicated, but modern tools like the mice package in R or built-in functions in SPSS, they handle all the heavy lifting. The process makes a lot of sense when you break it down. First, you inspect the pattern of missingness. Then, the algorithm creates multiple complete versions of your dataset, each with slightly different but plausible values filled in. You run your analysis on each of those datasets separately, and finally, you pull all those results together for a single, robust, and much more trustworthy answer.
I absolutely love this quote because it just reframes the entire task, doesn't it? You're not just cleaning data or filling in blanks. You are actively working to preserve the underlying truth that a messy, incomplete dataset is trying to obscure. It's a really critical part of the whole analytical process.
So the next time you see a blank cell in your spreadsheet, don't just see it as an error to be deleted. Take a second and ask yourself, what might that silence be trying to tell me? Because handling it the right way could be the difference between a flawed analysis and a true discovery.